Hi there, I'm Savannah.
And I'm Jimmy.
And we are from Dr. Steve Potter's 4752 Introductory Neuroscience class.
And so today we're reviewing Neubauer and Fink's review on intelligence and neural efficiency.
The article reviews the neural efficiency hypothesis, discusses its shortcomings, and suggests potential changes to the theory in light of contradictory evidence. Tasks in the brain are carried out by networks of neurons. The neural efficiency hypothesis suggests that the networks of more innately intelligent brains are more efficient, which means they consume less energy and show decreased activation in cognitive processing areas.
So basically people who aren't as intelligent have a lot more going on in their brains. It's just not efficient. And people who do have higher IQs can accomplish the same tasks with a lot less work.
Preliminary evidence from PET and fMRI have supported this theory.
Wait, PET?
PET scans.
Oh, right.
So, preliminary evidence from PET scans and fMRI have supported the theory of neural efficiency.
But neural efficiency isn't necessarily always the right answer.
The first evidence the article presents against the neural efficiency hypothesis is that it has only been supported in low to moderately challenging tasks.
Low challenging tasks? You mean like tying your shoes?
Yeah. In more challenging tasks,
like tying a bow tie, for instance.
Highly intelligent subjects actually showed an increase in brain activation.
Well, that's backwards than what they were saying earlier.
There is also evidence that there are differences in the brains of males and females related to neural efficiency.
Differences in the brains of males and females. We've known that for years.
In some studies, while women show deactivation only during verbal tasks.
Only during verbal tasks, like when they're yelling at their boyfriends. Right?
Males only show decreased activation when completing spatial tasks.
Well, luckily for males, spatial tasks also include taking over the world.
The authors in this article did not offer a potential explanation for this phenomenon.
Such a shame, and that seems to be a continuing problem.
Finally, the article discussed the implications of learning on the neural efficiency hypothesis. Learning has been shown in experimental groups of jugglers to increase the amount of gray matter in the temporal and parietal lobes.
Well, who would have known jugglers actually can build the sizes of their brains?
The London taxi driver study yielded similar results.
So basically, training for a task changes the brain, which makes all of this a lot more complicated.
We had a few issues with this article. Some of them were small and not too big of a deal, but some of them were larger.
For starters, the article is written in way too complex of terms. The concepts described don't take a neuroscientist to understand, but unfortunately, it seems like the entire article is written in, well, hieroglyphics would be easier to understand. Honestly, this article just needed to be written in plain Old English.
I mean, let's take a look at this one sentence. This influential idea has not been revived until the 50s of the previous century. Why can't you just say 1950s and be done?
Yeah, 50s of the previous century. I need a calculator and a calendar to figure out what that means. And in addition to that, they take their same concept about neural efficiency and repeat it throughout the entire article. It seems like the entire theme of the article should be repetition instead of efficiency. Repetition. The article never ends. Sound familiar? It's like that song from when we were kids.
This is the song that never ends.
Anyways, but to a bigger point, the article seems to take a lot of evidence and fit it to a theory that the authors are trying to put forth. It's like trying to fit a square peg into a round hole. Now, that doesn't sound familiar. You haven't seen Apollo 13.
Another problem that we had with this article is that it based everything that it was talking about on the definition of intelligence. But really, what is intelligence?
Intelligence could be remembering a fact. Intelligence could be the ability to learn a new task or to maybe even learn how to swing a golf club. So honestly, it's a big missing piece in the puzzle, and it takes a lot away from what they're trying to get across in terms of the efficiency and low versus high intelligence people.
And with the advent of neuroplasticity that's just coming on the horizon, the idea of innate intelligence is starting to really get questioned. It's kind of like the new phrenology.
So in full, the whole article has a lot of points that are just, well, flat out debatable. And it's hard to see whether or not their points actually validate their final conclusion, which is that neural efficiency only takes effect in menial tasks, which is really unfortunate because no one really cares what's happening in your brain when you're tying your shoe.